NENOMATICA, where mathematics meets YouTube excellence. In this video, we will solve a floor equation using a clear, step-by-step algorithm. The target form is the floor of ax plus b over c equals dx plus e over f. We'll label this as our example, and now show the equation in standard form on screen. Step 1. Standardize both sides as linear functions in x. We set y equal to the floor of mx plus n on the left, and y equal to m prime x plus n prime on the right, where m is r over c and n is b over c, while m prime is d over f and n prime is e over f. Step 2. Compare the slopes m and m prime. If the slopes are equal but the constants differ, there is no solution. If both slope and constant match, there are infinitely many solutions. Otherwise, if m is not equal to m prime, at least one solution exists, and possibly more. Step 3. Find the intersection of the two lines, y equals mx plus n, and y equals m prime x plus n prime. Solve mx plus n equals m prime x plus n prime, giving x naught equals n prime minus n over m minus m prime. Step 4. Compute y naught on the line. Y naught equals m prime x naught plus n prime. If y naught is an integer, then x naught is a valid solution. Otherwise, we will search around x naught guided by the slope comparison rule. Step 5. Use the directional rule. If m prime is greater than m, additional solutions may lie to the left of x naught. If m is greater than m prime, additional solutions may lie to the right of x naught. Let us now apply the algorithm to a concrete example. The floor of 2x plus 1 equals 3x minus 2. We will standardize, compare slopes, find x naught and y naught, check integrality, and then determine any additional solutions. Solve the intersection. 2x plus 1 equals 3x minus 2. This gives x naught equals 3. Substituting into the line, y naught equals 3 times 3 minus 2 equals 7, an integer. Because m prime is greater than m, we check to the left of x naught. Set 3x minus 2 equal to k, an integer. Then x equals k plus 2 over 3. Require floor of 2x plus 1 equals k. That is, k is less than or equal to 2x plus 1, and 2x plus 1 is less than k plus 1. Substituting x gives 3k, less than or equal to 2k plus 7, and 2k plus 7 is less than 3k plus 3. From these, k is greater than 4, and less than or equal to 7. So k equals 5, 6, or 7. Therefore, the x solutions are 7/3, 8/3, and 3. Final answer x equals 7/3, 8/3, and 3. Now let's verify graphically. We now draw both graphs. Y equals floor of 2x plus 1, which is a staircase, and y equals 3x minus 2, a straight line. We'll highlight their intersection points. In this lesson, we will solve a floor function equation step by step and visualize why only one value of x works. The equation is floor of open parenthesis 3x plus 7 over 5 close parenthesis equals 2x plus 23 over 7. Step 1 of the algorithm. Set the inner expression equal to the right-hand side and solve for x. Let y equal 3x plus 7 over 5. And also y equal 2x plus 23 over 7, so we equate them. Cross multiply. 7 times open parenthesis 3x plus 7 close parenthesis equals 5 times open parenthesis 2x plus 23 close parenthesis. That becomes 21x plus 49 equals 10x plus 115. So 11x equals 66, giving x equals 6. Now plug back to find y. 2 times 6 plus 23 over 7 equals 5. Since y is an integer, x equals 6 is a valid solution candidate. Step 2. Use a graph to understand why there may or may not be another solution. We will draw coordinate axes and plot both lines. y1 equals 3x plus 7 over 5, and y2 equals 2x plus 23 over 7. The blue line is y1, and the red line is y2. Their slopes are 3/5 and 2/7 respectively, so the blue slope is steeper. Notice they intersect at x equals 6, y equals 5. For the floor function, y must be an integer, so we draw horizontal dashed lines at y equals 5 and y equals 6. The algorithm says to also check y plus 1 on the shallower red line. Set 2x plus 23 over 7 equal to 6. Solving gives x equals 19 over 2, or 9.5. We will mark that x on the graph. Step 3. Verify the second candidate using the floor definition. If x equals 19 over 2, the left side is floor of open parenthesis 3 times 19 over 2 plus 7 close parenthesis over 5. That equals floor of 7.1, which is 7. The right side equals 6. Since 7 does not equal 6, the candidate 9.5 fails the equation. Therefore, the only solution is x equals 6. Summary. Setting the inner expression equal to the right side gave a valid integer, y at x equals 6. A second candidate from checking y plus 1 did not satisfy the floor equality. Final answer x equals 6. In this lesson, we will solve an equation that involves the floor function. The problem is left floor of open parenthesis 5x plus 19 close parenthesis over 8 right floor equals open parenthesis 6x minus 14 close parenthesis over 5. We will first find the intersection of the two straight lines as if there were no floor. Check if the y value is an integer, then compare slopes to decide how to get the second solution by stepping the output down by 1. Let's draw both lines on the same set of axes. The blue line is y equals open parenthesis 5x plus 19 close parenthesis over 8, and the gold line is y equals open parenthesis 6x minus 14 close parenthesis over 5. We will mark their intersection point and read its coordinates. Let's confirm the intersection algebraically. We set the two right-hand sides equal. 5x plus 19 over 8 equals 6x minus 14 over 5. Cross-multiply to get 5 times open parenthesis 5x plus 19 close parenthesis equals 8 times open parenthesis 6x minus 14 close parenthesis. That simplifies to 25x plus 95 equals 48x minus 112, giving 23x equals 207, so x equals 9. Substituting back, y equals 8, which is an integer. That means x equals 9 is a valid solution of the floor equation. Next, compare the slopes. The slope of the blue line is 5 over 8, and the slope of the gold line is 6 over 5. Since 5 over 8 is less than 6 over 5, the gold line rises faster. For the floor to work near the integer output 8, the next possible horizontal level is 7. That is one step down. We will intersect the gold line with y equals 7. Now solve the gold line with y equals 7. That gives 6x minus 14 over 5 equals 7. Multiply by 5 to get 6x minus 14 equals 35. Then 6x equals 49, so x equals 49 over 6. Let's plot that point at y equals 7 on the gold line. Finally, verify that the floor equals 7 at x equals 49 over 6. Compute the left side. Floor of open parenthesis 5 times 49 over 6 plus 19 close parenthesis over 8 equals floor of 359 over 48, which is 7. The right side is open parenthesis 6 times 49 over 6 times 49 over 6 minus 14 close parenthesis over 5 equals 35 over 5 equals 7. Since both sides equal 7, x equals 49 over 6 is also a valid solution. Therefore, the complete solution set is left brace 9, 49 over 6 right brace. In this example, we will solve an equation with an integer part bracket. First, look at the problem as written. Our goal is to find all real values of x that satisfy the equation. We will see the equation has infinitely many solutions, expressed by an integer parameter. The key idea is this. If the bracket which denotes the integer part returns the same number as the input, then the input must itself be an integer. We will turn the inside into an integer n, and then solve for x in terms of n. So we set 3x plus 7 over 5 equal to n, where n is any integer. Next, multiply both sides by 5 to clear the denominator. That gives us 3x plus 7 equals 5n. Now, subtract 7 from both sides to isolate the term with x. We get 3x equals 5n minus 7. Finally, divide both sides by 3 to solve for x. So x equals the quantity 5n minus 7, all over 3. This expresses all solutions using the integer parameter n. Quick check. If n equals 2, then x equals 10 minus 7 over 3, which is 1. Plugging back gives 3 times 1 plus 7 over 5, which is 2, an integer. So the bracket equals the same value. Our form is consistent. In this lesson, we will solve a floor function equation step by step. The equation is the floor of x over 3 equals 5x. We will visualize it and use a simple algorithm to find all solutions. Let's draw a coordinate plane and the two objects we care about. First, the blue step curve is y equals floor of x over 3. It is piecewise constant and jumps at multiples of 3. Next, the red line is y equals 5x. Intersections with the step levels are potential solutions. Step 1. If we ignore the floor for a moment and set x over 3 equal to 5x, then x equals 15x, which simplifies to 14x equals 0. So x equals 0. Substituting into the original equation gives floor of 0 over 3 equals 0. So 0 equals 0. Valid. Step 2. Compare slopes of the two straight lines we used. The slope of y equals x over 3 is 1/3, while the slope of y equals 5x is 5. Since 5 is much larger than 1/3, a second intersection can occur where the floor function level is an integer horizontal line near the origin. Step 3. Return to the diagram and draw the horizontal line y equals -1. Its intersection with y equals 5x occurs where 5x equals -1, so x equals -1/5. Now verify in the original equation. Floor of -1/15 equals -1, and 5 times -1/5 equals -1. Both sides match, so x equals -1/5 is also a solution. A quick intuition check. Whenever the floor of x over 3 equals an integer k, the equation forces 5x to equal k, so x must equal k over 5. Checking which integers k satisfy floor of k over 15 equals k leaves only k equals 0 and k equals -1. That exactly yields x equals 0 and x equals -1/5. Great work! In this lesson, we will solve the equation that uses the floor function. We will follow the exact algorithm and the precise order of steps shown in the reference. Step 1. Simplify the fraction inside the floor. We rewrite the numerator as x plus 1 plus 1, and then split the fraction to see an integer plus a remainder. Step 2. Extract the integer from the floor using the property that the floor of n plus a equals n plus the floor of a when n is an integer. Here, n equals 1. Step 3. Move 1 to the right side to isolate the floor term. This gives the floor of 1 over x plus 1 equals x minus 3 over 2. Step 4. Change a variable. Because the floor always returns an integer, we set the right side equal to k, an integer. So x minus 3 over 2 equals k, which gives x equals 2k plus 3. Step 5. Substitute x equals 2k plus 3 back into the floor expression on the left. We get the floor of 1 over parentheses, 2k plus 3 close parentheses, plus 1 equals k. That simplifies to the floor of 1 over 2k plus 4 equals k. Therefore, the only possible value is k equals 0. Then x equals 2 times 0 plus 3, which is 3. In this lesson, we will solve a classic floor function equation, following the step-by-step structure shown in the provided method. The equation to solve is floor of open parenthesis 4x plus 1 over 2 close parenthesis equals x plus 2. Our goal is to solve for x and carefully justify every step. Step 1. Because the left side is a floor, its value is always an integer. So we set the right side equal to an integer k. That is, x plus 2 equals k, where k is an integer. Solving for x, we get x equals k minus 2. Step 2. Now substitute x equals k minus 2 into the original equation. And since x plus 2 equals k, the right side becomes k. We get floor of open parenthesis 4 times k minus 2 plus 1, all over 2 close parenthesis equals k. Step 3. Distribute and simplify the numerator. 4 times k minus 2 gives 4k minus 8. Adding 1 gives 4k minus 8 plus 1. Combine like terms to get 4k minus 7 in the numerator. Step 4. Separate the fraction into two parts. Floor of open parenthesis 4k over 2 minus 7 over 2 close parenthesis equals k. To align with the target method, Rewrite the numerator as 4k minus 8 plus 1. Then split so that one part is an integer, floor of open parenthesis 2k minus 4 plus 1/2 close parenthesis equals k. Step 5. Use the property, the floor of n plus z equals n plus floor of z, when n is an integer. Here, 2k minus 4 is an integer. So we take it out of the floor. We get 2k minus 4 plus floor of 1/2 equals k. Step 6. Evaluate floor of 1/2. Since 1/2 is 0.5, the greatest integer less than or equal to it is 0. Therefore, 2k minus 4 plus 0 equals k. Step 7. Solve for k. 2k minus 4 equals k. So subtract k from both sides to get k minus 4 equals 0. Hence k equals 4. Step 8. From x equals k minus 2, substitute k equals 4 to get x equals 2. Finally, check the solution in the original equation. Floor of open parenthesis 4 times 2 plus 1 over 2 close parenthesis equals floor of 9 over 2, which is floor of 4.5, equal to 4, and the right side x plus 2 is also 4. The solution checks. Thank you for watching. Don't forget to like, subscribe, and hit the bell icon for more math lessons. NENOMATICA, where mathematics meets YouTube excellence.